Now we're going to talk about finding maximum and minimum values of functions. So back when you had just one variable, you would look for places where the derivative was 0, and you called those critical points, x sub c. And then you had the second derivative test. So if the second derivative was positive at the critical point, you had a min. If it was negative, you had a maximum. And if it was 0, well, it could be anything. Okay, now for functions of more than one variable, we're looking for the gradient to be 0. So r sub c is a critical point in space. For the second derivative test, we end up using all the second derivatives in this determinant that we call d. If d is greater than 0, then we have to do one more test. If x of double x is greater than 0, you have a minimum. If f double x is less than 0, you have a maximum. Then if d is less than 0, you have neither. It's a special kind of point called a saddle. At a saddle point, the function is increasing in one direction and decreasing in another, so it has neither a max nor a min. And then if d were to happen to be 0, again, you wouldn't know what's going on. Remember, in these problems, there's the difference between the local max and min and the global one or the absolute one. And that changes how you end up solving the problem.